Hi, today we're looking at Hitori, which is a number-based puzzle, although not one that involves any arithmetic or mathematics. So if you don't like adding up, don't worry, there isn't any in this one. We can have a look at this one style puzzle to see what Hitori is all about. This puzzle is from Puzzle Weekly Presents Hitori. There's a link in the description if you want to have a look at that. Play along on the puzzle yourself or have a go at some harder ones. So what's Hitori all about? Well, we're playing on a square grid. You can see looks a bit like a completed Sudoku, doesn't it? But this is an uncompleted puzzle. And the objective of this puzzle is to cross out or shade in numbers in such a way that we do not have duplicate numbers appearing on any row or column. So if we look at this row along here, for example, you can see that we've got the number 5 appearing twice and the number 3 appearing twice. So we need to cross out one of those 5s and one of those 3s. We don't want duplicates appearing on rows horizontally, and we don't want them appearing on columns vertically either. And there's one other rule that we need to be aware of, and that is that shaded or crossed out cells cannot touch orthogonally or next to each other horizontally or vertically. So if we shade in, for example, this cell here, then we could not also shade in that one, or that one, or that one, or that one. But we're not worried about shading cells that touch diagonally. That's fine. So that's the objective, that's the rule, is how do we go about solving one of these puzzles? Well, we do so by using a combination of elimination, crossing out cells that we know we have to get rid of, and also we can use kind of opposite elimination strategy where we highlight cells that we know or numbers that we know must be kept. And to do that, we can look for some patterns. Now, this is only a very small puzzle, so there aren't that many patterns on here, but there are a couple we can look at. And the first one is what we call a 2+1 pattern. There's an example of it here. You can see we've got the number 2 appearing twice there and a third time here. So this is our 2 and this is our +1, if you like. And there's a 4 in between. Not worried about the 4. What interests me is that with these two 2's here, we know that we can't shade two cells that touch orthogonally. So if we were to cross out this cell, then we know we would have to keep this one. We can't cross them both out. And if we were to cross this one out, we would have to keep this one. Either way, we're going to have to keep one of these two, which means we have to remove this one because we can't have a duplicate number. So this 2+1 pattern tells us that the +1, this one here, has to be crossed out. So let's do that now. Just to cross through that. Now when we cross out a number, because we know that we cannot cross out any number that is orthogonally adjacent, that means these 4 numbers cannot be crossed out. So what we can do is we can circle those to remind ourselves that they must be kept. Now, there's one other pattern we can look at before we come back over at these circled numbers, because these circled numbers are pretty useful. But before we do that, I just want to show you another pattern. And let's have a look as an example of this pattern down here. And I call this one an X, Y, X pattern. If we imagine this is X, this is Y, and this is X again because it's the same number, but it has 3, 6, 3. Well, we know that we cannot have 2 3s in this row. That's against the rules. So one of these 3s is going to have to cross out. Doesn't matter which one we cross out, if it's that one or that one, either way, we won't be able to cross out the cell in the middle here. So we can also put a circle around that because we know we must keep it. Now we got another of those X, Y, X patterns here on the vertical on this column. And there's 3 here and a 3 here. Now we'd always circle this 3, so we know we're going to cross this one out anyway, but let's just pretend for a moment we didn't know that. That is, we know we can circle this 5, so let's stick a circle around the 5. Just check if there's any more of those. We have 5, 3, 5 here, so we can circle the 3 in the middle. Over 2, 6, 2 here, so we can circle the 6. Then we've also got a 6, 2, 6 here, so we can circle the 2, can't we? Okay, so let's come back and look at the circles because I said that these circled numbers are useful. And indeed they are useful because if we come back and look at the first row again, and we circled this 3 up here, didn't we? We know we have to keep the 3. Therefore, any other 3s in this row can be shaded. Well, there's a 1 here, so that can be crossed out. And we can also look down a column and see if there are any more 3s there. Because again, we're keeping this 3, so we can't have any other 3s in this column. which means this one's going to have to go down here. So we can cross that out. Again, we know when we cross out a cell, like this 3 here, any adjacent and orthogonally adjacent cells must be kept, because we can't have 2 crosses touching each other. We can't have 2 shaded cells touching each other. Therefore, we can circle here, here, and here. And we could look at this cross we made down here, and we could circle here and here. And now it's just a cascading sequence of circles and crosses, isn't it? If we carry on, well, we'll carry on walking across this way like that. We circled the 5, which means we can cross out this 5. And there are no 5s that way. We circled this 1. Well, there's no 1s there, and there are no 1s there. Then we carry on, come down, look at this row. We circled this 3. So there's no 3s along there, but there is a 3 down here. So we can cross that one out. And if we're crossing this out, then we can circle the cells adjacent, which is that one. That one. Where did we get to? We looked at that 3, didn't we? Now we're looking at the 4. Well, we've got no 4s in the row, but we have got a 4 down here. So we can cross that out and circle either side of it. We've got the 2 here, so we can cross out this 2 and this one down here. Now we've got a 5 here, which means we can cross out this 5 here and circle the 2 next to it. And anything else? We haven't got many cells left. This 6 means we can cross this one out, keep that and that. And I believe that means we've actually completed the puzzle. Now, this is an interesting thing with Hitori, is that unlike something like Sudoku, where you can place a final digit and see immediately that you've completed the puzzle, with Hitori, the only way you know you've completed the puzzle is by constantly checking to make sure you have no duplicates anywhere in any row or column. There's no obvious marks that you can place that says that's it, you've just finished. So I'm just going to double check. 3, 2, 5, 1, 3, 4, 2, 6, 5, 1, 3, 6, 3. So that is correct. We've solved the puzzle. Now, I did say it was an easy one, and we didn't need that many patterns, did we? Once we got started, we had a cascading effect of drawing circles and crosses that gave us more circles, that allowed us to then cross out more and more until we were done. This is what a much rather puzzle looks like. This is puzzle number 108 from the same book. Obviously, considerably more difficult, far more cells to consider. If you'd like to have a go, Hitori yourselves, check the link in the description and you can download a taster pack with a few puzzles. There's a couple of easy level ones like this, and slightly more difficult ones as well, to give you a little bit more of a challenge.
Hello, I'm Auntie. Don't forget you can get our Puzzle Weekly magazine delivered to you every Monday, completely free. Visit the link to get your copy.